name is Benjamin Weigel, and I'll be talking about our recent work on how we detect shifts in fish larvae phenology. So changes in the phenology of species are considered to be the fingerprint of climate change, since they are most often linked to increasing temperatures. On land, getting suitable data for documenting phenology shifts might be tedious, but also seems quite straightforward. One just needs to go out and record the first flowering date of plants, the first flight dates of butterflies, or the departure or return of migrating birds. However, when moving to aquatic species, this is somewhat more tricky, as their development is much less obvious to observe, besides maybe the formation of phytoplankton blooms. So one common problem in studying this changes in phenology is the lack of suitable data. Now, for commercially important fish species, there are fish larvae surveys, but those are often not suitable for detecting phenology changes, as they are done during the peak spawning times and miss the onset of the spawning, with their purpose basically being to inform fish stock assessments and fisheries management. So the solution to this is now to develop a measure to study phenological changes in fish larvae surveys, in fish larvae using the fish larvae surveys. And we do this for the Baltic herring. So in theory, the survey period only starts once there's already spawning going on. So we have spawning before the survey period as well as after. And over time, the smallest larvae grow into bigger larvae, while there's a continuous supply of more small larvae as the stock keeps spawning. Now, with the spawning time and the larvae growth being a function of temperature, we can expect that increasing temperatures over time would lead to faster larvae growth or earlier spawning. So we hypothesize that the temperature-dependent spawning and growth cues have led to earlier development. Since now there's no information on the exact first dates of larvae hatching available, we suggest two phenology measures based on the probability of occurrences of the smallest larvae and of the fractions of three different size classes. So earlier dates in high occurrence probabilities of smallest larvae would indicate relative earlier spawning, and earlier dates in high fractions of the largest larvae would indicate a faster development. So we used long-term herring survey data over 20 years and collected at 7 different areas covering the coast of Finland to find this out. Each area was then divided in 5 to 6 sites where transects were sampled every 10 days between mid-May and August. And as explanatory covariates in our model, we included sea surface temperature, salinity, the amount of chlorophyll A, and to account for density dependence, also the spawning stock biomass. So what we find now is that looking at all areas combined, we do see both. We see earlier occurrences of smallest larvae as well as faster development by having a large proportion of big larvae earlier in the season. And this change is actually by more than a week earlier per decade on average. So what does this mean? So temporal changes in the life cycle of the Baltic herring can become critical for the survival of species when there is a mismatch in timing between prey and consumer, especially during the early stages. But due to lack of data of other trophic levels, we could not take this into account or study the relation. So this is something which is going to be important to see. But the main aspect is that our modeling framework can now basically provide a solution to highlight phenological shifts in early life stages of species, especially fish, for survey data where there's not necessarily the onset of the reproduction covered. So if I could raise your curiosity about this, please have a look and see our latest publication in Marine Ecology Progress Series for some more details. Thanks.